Good day, guys. Welcome once again. For today, we are now going to move over to the second part of arithmetic progressions. You would find that in the part 1, we had done with simple examples, but now we're going to go on to something a bit more interesting, at the same time not much more challenging. Topic number 1, still stuck with numbers. And guys, we are dealing with arithmetic progressions part 2. If you are catching up with part 2, please watch part 1. What we have done so far, to tell you the truth, is very boring. This is an arithmetic sequence as discussed in part 1. 1, 3, 5, 7, and on and on and on. This is an arithmetic series. 1 plus 3 plus 5 plus 7. A sequence, a series. So, what is the difference? There's the difference. In an arithmetic series, the variables or the digits are separated by a plus sign, whereas in a sequence, it is separated by a comma. Plus, comma, plus, comma. And that is your fundamental difference between an arithmetic series and an arithmetic sequence. Arithmetic series. If the terms of an arithmetic progression or sequence are added to one another, the result is known as an arithmetic series. So if I take a progression and I add up all the values, that now becomes an arithmetic series. Now if we were given the following arithmetic series, 1 plus 3 plus 5 plus 7, the first term is 1. This term over here is still 1. And the common difference is 2. And just to recap, the common difference is T2 minus T1 or T3 minus T2. In this case, 5 minus 3 is equal to 2. The sum of the first 5 terms is easy. We simply add the first 5 terms, which is 1 plus 3 plus 5 plus 7 plus 9. And that gives you a total of 25. Now you might be asking, so what is the hassle in this type of problem? Well, the problem comes in here. What if we were now asked to find the sum of the first 20 terms of the series? Now, it is no longer as easy because 20 terms will go on and on and on until you cover the sum of the first 20 terms. Now again, there must be something that could be done about this. There must be an easier way. And lo and behold, there is an easier way. An easier way by making use of an equation. This formula is the formula for the sum to n terms of an arithmetic series. The formula may seem cumbersome, but we know what the variables stand for. And in the exams, guys, this formula will be given to you. This n will be the number of terms that we're dealing with. For example, if I ask you what is the sum of the first 50 terms, n is 50. The sum of the first 10 terms, n is 10. A, we know, is the first term. No changes. This n is the same as that n, which is the same as that n. D is the common difference. So we understand the common difference as being T2 minus T1. No difference again. If we were given the following arithmetic series, the first term is 1 and the common difference is 2. Now my question reads, find the sum of the first 20 terms. So in order to do this, I will say I have an equation for the sum of the first 20 terms, and it goes as follows. What is n? N is equal to 20. What is the value for a, guys, before we go further? A is equal to 1. What is the value of d? D is equal to 2. So I have here a, which is equal to 1. I have d, which is equal to 2. All I do now is I substitute into the formula. N is 20, a is equal to 1, n is equal to 20, d is equal to 2. And that is the basic idea. And all I do after that, guys, is use my calculator, use some logic, and I get to the answer. 20 divided by 2 is 10. This is 2. 20 minus 1 is 19, times 2 is 38. 2 plus 38 is 40, times 10 is equal to 400. Now, how about proving this to you? Let's say I go and write down the first 20 terms. And they are my first 20 terms. What happens now if I add up all the 20 terms? To make it easier, I simply add it down here. I get 64, 72, 80, 88, and 96. And if I add up all these values, I end up with a nice answer of 400, which proves to me that this equation up here really works. Now, one more time, guys, when you are working with examples like this, please ensure you know what the N is, the A, and the D. Let's go further. Worked example number 2. Given the following series, 12, 17, 22 plus 27, determine the sum of the first 18 terms of this arithmetic series. Again, guys, I want you to get the sum of the first 18 terms. You know you have two formulas. You have a formula which tells you to calculate Tn, which gives me a specific term, and you have a formula that gives me to calculate or allows me to calculate Sn, which is the sum. So between that and that, automatically you know we are using the sum formula. And I will say A is the first term, which is equal to 12. The common difference is the 17 minus 12, which is equal to 5. And I'm working out the sum of the first 18 terms. My equation, I copy it straight from my formula sheet. Remember, N is 18, A is 12, D is equal to 5. What could be more easier? All I have to do is to substitute into the correct area. And once I do the correct substitution, I end up with an answer of 981. Now, please, guys, do not get this part correct and not know how to use your calculator. Let's go to another example. Example number 2. It says, calculate the sum of the first 35 terms of an arithmetic progression if the first term is 10 and the 35th term is 210. Now it says here, I need to calculate the sum of what? The first 35 terms. So I know immediately, what am I calculating, guys? I'm calculating S35. Thank you very much. The first term is 10, which means A is equal to 10. Now they go and they confuse me a bit, because they tell me that 35th term is 210. So which means I know that the 35th term is equal to 210. Now that's basically the information I have in this example. Furthermore, I go here and I would say, but wait a second. Calculate the sum of the first 35 terms and the 35th term is 210. Which means this T35 over here is the last term in this series that I'm using. T35 is the last because I want to only calculate the first 35 terms. Which means now L is equal to 210. Why? The 35th term is 210, and what is the 35th term? The 35th term is my last term. And L stands for the last term. So when you work with these guys, please ensure that you understand that there is a formula to calculate the sum of a number of terms, provided that I know what the last term is. It did not specify very nicely, but in your examples for the exams, they will say the first term is, let's say, 5 and the last term is 210. If I substitute into this formula, N is equal to 35, A is equal to 10, and what is my last term? My last term is 210. Again, simple substitution. I end up with the sum of the first 35 terms, which is 3,850. Quite a simple example. One more time, guys, your examples in your exams will specify something about a last term, and then you know you have a sum formula. So to recap, I have a formula for Tn, which tells me a specific term. I have two formulas for Sn. Right? One of them deals with a last term. And this is the one, or the formula for the last term. Let's go over to an activity, guys. This is a long activity. We're going to spend quite some time dealing with the answers. For now, you copy the activity down. In example number 4, guys, those of you that have done the quadratic equation in schools, you can try that. For the rest of you, no need to worry much about it. It's not in the syllabus. Wow, what a car. And with that being done, guys, please, you can pause your screen and go ahead and work the examples out first. Okay, guys, solutions. Right, given this is a series, determine the 10th term and the sum of the first 20 terms. 20 terms, sorry about that. Okay, first and foremost, guys, you know that is A. You would know how to calculate the value for D. D will be the 37 minus that, so D is equal to 7. Guys, we know that. Determine the 10th term, straight away you know you are calculating Tn. Determine the sum of the first 20 terms, you know you are calculating S20. Perfect. Example number 2. Find the sum of the first 12 terms. What are you asked to calculate, guys? S12. The first term is 10 and the common difference is 8. Perfect. The answer here is 648. Find the sum of the first 7 terms. What are you calculating, guys? Sn. The first term is minus 3 and the common difference is minus 2. Perfect. The answer for this is minus 63. And question number 4. This is the one, guys, I told you to watch out for, but nonetheless, let's have a look at it. The sum of an arithmetic series is 207. So they tell me the sum of this series here is 270. The common difference is 1. That's D. And the first term is 4. Calculate the number of terms in the series. So guys, if I look at this, I use the formula SO. But now the difference is Sn is equal to 270. I don't know the value for n because they ask me calculate the number of terms in this series. A is equal to 4, D is equal to 1. You substitute that into the formula, guys, and you end up with n squared plus 7n minus 540 is equal to 0. So for those of you that have done the quadratic formula in school, if you want to calculate the value for n, you'll say n is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. And from here, we know the value for a is equal to 1. The value for B is equal to 7 and the value for C is equal to 540. Alright, ask your lecture in front of you if you need the answers for this one. Alright, question number 5. The sum of the first 15 terms is 165. So it means Sn is equal to 165. The common difference is 2, which means D is equal to 2. Calculate the first term of the sequence, which means you have to calculate the value for A. And guys, I substitute into the formula, I manipulate this formula, and I end up with the value of A. Question number 6. It says, now this is more of an exam type, right? It says, calculate the sum of the first 15 terms of the sequence. You're calculating S15. If the first term is 3 and the 15 term is 78. Now in this case, I'm only working to 15 terms, so this becomes my last term. Very, very similar to the example that I had done with you. Chantal bought the following car in an auction. I wrote this down here because I just want you to see exactly what is going on here. She paid 440,000 rand for it. Now this car depreciated to a value of 400,000 at the end of the first year. The second year it was 360, and the third year it was 320. Now watch what happens. These are the numbers: 440, 400, 360, and 320. What is the value of the car at the end of the 10th year? And how many years would it take the value of the car to be 160,000? Typical exam type question too. Starting off, guys, this is your value for A because it's the initial amount. Remember, this car depreciates. How would I get the value for D? D will be 400,000 minus 440, or 360 minus 400,000, and that's where I get the A, and I get the common difference, which is minus 40,000. Now what is the value of the car at the end of the 10th year? I need to calculate T10. To calculate T10, I substitute and I get to the answer. After how many years will it reach 160,000? Which means this value is 160,000. I need to calculate the value for N. Substitute and you get the answer. N is equal to 6. Almost there, guys. Calculate the sum of the first 15 terms of an arithmetic progression if the first term is minus 20 and the 15th term is 40. Now guys, this again is quite simple. It's quite straightforward. Right, number 9. I will always do my maths homework. I will always do my maths homework. I will always do my maths homework. Ensure that you do. A is equal to 18. The common difference is equal to 8 because it's asking to write it 8 times more, right? T24, simple. S16, simple. And the last one, guys. On this one, you would find a pattern is being given, no numbers. But I can develop the numbers from the pattern. And this is something that you need to be able to do. How many motives are there? There's 3. How many here? 3, 4, 5, 6, 7. How many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my sequence is 3, 7, 11, and it can go on and on and on. Where A is equal to 3, my difference is 7 minus 3, which is equal to 4. T18, very simple to calculate. And lastly, the sum to 30, or the sum of S30, is 1,830. So by the time she reaches the 30th shape, she would have used 1,830 motives. Thank you, guys.